Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming. A very good morning to you, and you're very welcome to today's Signpost webinar. I hope you're keeping safe and well. So this series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland, the National Rural Network, and Food Drink Ireland SkillNet. So let's remind ourselves why we are here today. Since the 1800s, the world has warmed by 1.1 degrees, and each of the last 4 decades has been warmer than any decade since 1850. In its latest report, the Intergovernmental Panel on Climate Change, or IPCC, has stated that it is now an established fact that human-caused greenhouse gas emissions have led to an increased frequency and/or intensity of some weather and climate extremes since pre-industrial times. And this can explain some of the more unusual weather events that we have been experiencing in Ireland in recent times. So today, we're going to talk about how farmers can reduce their greenhouse emissions, gas emissions, and save money at a time when, particularly in a landscape where fertilizer prices are an all-time high. And we're delighted to be joined by Dr. Patrick Forrestal, who's a researcher in Johnstown Castle. Good morning, Patrick. How are you today?
Good morning, Mark, and good morning, everyone. Thanks for joining in today.
And we're also joined by Pat Murphy, who's head of the KT Environment Programme. Good morning, Pat. How are you today?
Morning. Great. Not a bother.
So, Patrick, maybe you could tell us about the work that you're doing in Johnstown Castle before we get into the presentation.
Yeah, very good. Look, and thanks for the invite to come and speak today. At Johnstown Castle, myself and the other colleagues there at the research centre, a lot of the work that we're doing is looking at how do we sustain production and productivity of our systems, but find the wins that could be there to deliver solutions for reduced emissions, be those greenhouse gas emissions, ammonia emissions, or reduced loss of nutrients to water, and I suppose to try and come up with those practical solutions that farmers can implement to try and make those reductions. And look, we also do work to figure out just what level of emissions are coming from different fertilizers or different options, and that goes into feed and refine inventories around those emissions. So in some of the work we've done in the past, we found actually the emissions coming from certain inputs like dung and urine, for instance, were lower than was assumed. So there were savings to be made there. So that's one example of work that we do in that space. But I suppose also we're looking for, can we achieve the same end result in terms of production with a lower emission footprint and lower absolute emissions? And I'll speak a little bit about some of those opportunities today.
Great. Okay, super. So you're going to give us maybe some of the practical advice, but also some of the science behind that. So Patrick, we'll hand over to you and we will chat to you after the presentation.
Very good. Thank you, Mark. Look, good to have everyone on here this morning. And look, we'll talk through, I suppose, some issues that are quite topical at the moment. I think the price of fertilizer is at the forefront of everyone's mind as we come into that fertilizer spreading season. And in today's presentation, I'll talk about some tips based on the research that we've been doing recently that could play a role in helping save you money and also reducing emissions on your farm. So I suppose technologies or options or things that you can do that can help to save some money, but also have that win on the climate side of things or the emission side of things. And I suppose it's important for us to recognize that those emissions and the water quality, etc., those things are being measured and they do feed back, the progress that we made do feed back into, I suppose, the overall context of how we're going to be farming going into the future. So it's good to keep that in mind. So look at the first thing I want to say is that the knowledge that you have of your own farm, that knowledge is very, very powerful. The soils of Ireland, they're very diverse. As you can see here from some pictures of various soils that I've been involved in doing trial work or management on, and this is just a fraction of those soils. So the soils, the aspect of those soils, the exposure that they have, the drainage of them, these type of factors all affect things like how fast will they warm up in the spring, which has implications in terms of putting out nitrogen and what sort of fields or areas might it be more of a gamble in terms of response versus others, how they're going to lock up phosphorus, how buffered they are in terms of how much lime it's going to take to adjust their pH. Maybe they're peat soils and they need some different management than mineral soils. So these type of factors, these better than anyone, and certainly better than I for your farm. So I suppose what we want to add to this is a layer of tips that you could implement on your farm to sort of build on that knowledge that you already have. And of course, soil sampling and having a soil test is one of those key aspects, which has been, I suppose, much talked about, but is a very powerful tool. Now look, at nitrogen prices are very high. Last year, Irish agriculture used something in the order of around 400,000 tons of nitrogen nutrient. So that's not of product, that would be many more tons, but of nitrogen nutrient closing in on 400,000 tons. In very broad terms, that cost around 400 million euros to farmers. Now with fertilizer prices being 2.5 or 3 times higher, and if they're sustained through the year, we use a similar amount of nitrogen, that's going to cost more than €1 billion. So this is a huge additional cost to the agriculture industry. And I suppose there's not much getting away from the fact that we do have this opportunity to, if you like, grow our own nitrogen by use of legumes. And by introducing those, reduce or wean off to some extent our reliance on mineral imported fertilizer nitrogen, which is generally imported from either outside of Europe or made within Europe, often relying on natural gas that's imported into Europe. And I suppose that presents a little bit of a risk to our system just in terms of getting access to it and that cost fluctuation, which I suppose has been particularly pronounced in the present year. So look, in terms of bringing clover into swards, there's some really nice work and guidance there that's been done and developed by colleagues including James Humphreys and Deirdre Hennessy and Brian McCarthy and Mike Egan, just in terms of getting that into the sward there. But I suppose one thing I wanted to bring to that also from a pH trial that we've been running at Johnstown Castle, where you see here there's pH in this replicated setup running from the mid pH 5 up to close to pH 6.8 in this case, but close to 7. So this was a grass sward receiving 150 kilograms of N per hectare, where we overseeded clover in 2020. And this was the impact of pH on the grass yield of that overseeded sward in 2021. So you can see a very marked effect of soil pH on the success of the clover in that sward in terms of benefiting yield. So look, in the coming year, many of you may be thinking about clover, introducing it either by stitching it in or reseeding, including clover. And I know with clover there is additional management there, but if you think about it in terms of the current prices, like if you can realize a 75 kilogram per hectare saving in nitrogen, that's close to 10,000 euros on a 50 hectare farm. And of course, you're less reliant on fertilizer nitrogen, and there's less greenhouse gas emissions associated with that. And that would also be reflected in our nitrogen, in the overall inventory of emissions. So we get a benefit there. So really the tip that I have for you this morning is, look, I know that clover is not an overnight, you're not going to get it into the sward overnight, but on many farms, there may be some clover that's ticking away there in swards. You can give that clover a boost for the coming year with lime, where your pH is lower in those mineral soils. And many people are thinking of pulling their nitrogen rate back slightly, or maybe more than slightly, and that reduction in nitrogen will also help the clover. So those are two things that will help the clover in sward where it exists already. And if you're thinking of establishing clover by whatever means, really your first step is to lift the pH. You're not setting yourself up for success for that investment to try and do that if you don't lift the pH first. Really, you're talking about getting up into the mid sixes, that sort of level is a better place to be than, let's say, certainly if you're below 6, you're not in a good place to start trying to add clover in the mineral soils. So that leads us to the question of, look, do you know the pH of each field on your farm at present? And the soil testing point that's been mentioned, I suppose you've heard again and again, but in this particular year, it's particularly important. So if the answer is no, you don't know offhand, well, one thing you could do is you could dig out the last soil samples and see what they said. That would give you some sort of a guide, just in terms of where you are. If you haven't added lime, likelihood is that the pH has declined, and prioritize soil sampling. I know it's a busy time on farms with calving, etc. But if you have the chance to prioritize soil sampling, get that information, it's really a year where that investment is worthwhile, more so than, or certainly to an extra level than it usually is. Based on that information, you can spread lime as required. We're coming into a time of the year where people are maybe hesitating about spreading lime because, right, they've got slurry that they want to spread, and what about issues there? Look, if you wait 7 to 10 days after slurry application for your lime application, you should be okay. There's not an issue there. It's not ideal before slurry, and that's why there's guidance there to wait a number of months after lime application before applying slurry. But I suppose the nuance that I would add to that is, if you're using the low emission spreaders and you've got dull, cool conditions, that level of loss would be minimized in comparison to if you're going out with a splash plate on a windy, bright day. So there are things that you can do there by just using your own management at your own site, given the weather conditions and the equipment that you're using, that could squeeze that window. And getting lime on is really important for the clover. Also, I suppose the question comes up around, what about lime with protected urea? I'm thinking of using protected urea this year, and I'm hesitant to lime. I did some preliminary work in Johnstown Castle, where I applied protected urea onto these plates, straight onto lime, and the protected urea didn't seem to have increased emissions of ammonia or loss of nitrogen where it was applied to those lime soils. So that seems to be okay. So I suppose the message is, get the lime on, and that lime is, I suppose, relatively good value in that its price hasn't moved, certainly to the extent that the fertilizer prices have moved. And even with the fertilizer prices going up and nitrogen particularly jumping up, phosphorus is still the most expensive nutrient to purchase. And what we see here is another trial from Johnstown Castle, where we have a range of replicated pHs from 5 all the way up to 6.6. And you can see here on this, as we increase pH, the Morgan soil test value, which is indicating the available phosphorus, is increasing, and particularly when we get into above pH 6. So that available P that's there is being released by adding lime. And look, for this particular soil type, we're seeing it, and this is in agreement with work on other soil types. So this seems to be a quite a universal effect. This is quite a universal chemically driven effect across a range of soils. So the tip that I would bring to you around phosphorus is, look, fertilizer is expensive. Why not try and unlock as much of the phosphorus that you already have with lime, and so try and supply more of your phosphorus requirement to the plant using lime. And I suppose just to put some figures on this, about 6 kilograms of phosphorus, or 12 units of phosphorus, that's about all the phosphorus you're going to get for the price of a ton of lime, in or around that. So look, lime is a good value fertilizer. And on the emissions theme, this is some work just off the presses in 2021. The team in Johnstown looked at, is there emission saving from increasing the pH up to the optimum level or a little beyond it? And we can see in this paper the relationship between soil pH here along the horizontal axis and cumulative nitrous oxide emissions, so nitrous oxide being a very potent greenhouse gas. And we see that declining trend in cumulative nitrous oxide emissions as the soil pH increases. So correcting your soil pH, bringing it up into an optimum range, that can also play a role in reducing greenhouse gas emissions. So there's a win there, and that's a reduction, even considering that there is some greenhouse gas emission associated with the CO2 release when we spread lime. However, because nitrous oxide is such a potent greenhouse gas, there's a benefit there. Now we all know that nitrogen fertilizer prices are high, as are they for fertilizers generally, and I'm sure a lot of you are reeling from the quotes you've gotten from fertilizer for the coming year. And I want to bring into the conversation some work that we've been doing as part of 2 EU-funded projects, Renew to Farm and Nutri to Cycle, where we've been looking at, I suppose, what's going to become a more important area in the coming decade and beyond, where there's more of a focus on recycling waste streams and bringing them back into agriculture as nutrient sources. So instead of the system where we purchase mineral fertilizer that's been mined or broken out of the air in the case of nitrogen, and then the food is produced and those nutrients are lost in waste streams, that is recaptured. And that's particularly important for us for phosphorus, and as we're seeing now for nitrogen in Europe, because we depend on importing phosphorus in particular from outside of Europe. And these bio-based fertilizers, as they're referred to, can recapture these nutrients and put them in. So look, we've been doing some work on these. If you haven't heard of them before, that's good. I suppose I want to share a little bit about this developing area, if you like. So we looked at the performance of this struvite. So really, if you've got any phosphorus-rich wastewater stream, they can precipitate out the phosphorus into this struvite material. Here it is, typically 6 to 8% P, sometimes higher, but that's kind of what we were working with in this particular study. Ash material, so this could be, in this case, combusted sewage sludge or poultry litter ash. These deliver nutrients, and of course the dairy processing sludges. And there's a large amount of these being generated as a byproduct of our dairy processing industry here in Ireland. A number of years ago, a colleague estimated this to be in the region of 140,000 tons of material nationally, and it's likely that has increased. So look, we looked at 2 dairy processing sludges, one calcium precipitated and one aluminium precipitated dairy sludge. So look, at these may be nutrient sources that are available close by to you, and many farmers are already using them, or a good number of farmers are. And of course you've got cattle slurry, a resource that you've got on the farm itself. If you can't, and if you like, in a sense, that's a bio-based fertilizer that you're managing. And I think we've got scope to do better with slurry, which is an opportunity there for us. And additionally, it can bring some extra things to the party, as we'll talk about here shortly. So look, I suppose the tip is have a look around locally, see what might be available to you in terms of these bio-based or recycled fertilizers, and making the best use of slurry is also an opportunity that we'll talk a little bit more of. So look, one of the things we wanted to do with these materials was right, they're not the same as conventional mineral fertilizers, so how available are the nutrients in them? We've previously looked at the dairy processing sludges. They do contain some nitrogen as well, but typically that nitrogen was not as available as mineral nitrogen, in the range 20 to 40% availability compared to calcium ammonium nitrate. So a nitrogen source, but not available to the same extent. So what about on the phosphorus side? We put these out in a field trial that ran for actually 3 years with a single application of phosphorus at the beginning, and subsequently we cut them and applied, we took off silage cuts without any P, but we put on nitrogen, potassium, and sulfur to make sure that those weren't limited, essentially to draw down that phosphorus and see how much of it could we get back into the plant. So if we looked at the superphosphate as if you like our mineral fertilizer base comparison, up here you're looking at apparent P recovery. So this is the recovery of phosphorus that was applied minus off what the control or background supplied. This was an index 1 soil, so it needed phosphorus. And if we look at the very first harvest, so that big first cut silage, how much of the P that we applied did we get back into the plant? It was about 10% apparent P recovery for the super P for that first harvest. So I suppose this drives home also that when you apply a readily available phosphorus source to soils, there's a competition there for lockup of that phosphorus. And that's why going back to liming is so important to keep it available, so it's not getting locked up in the soil at those lower pH levels. But look, I suppose generally what we see is that a cattle slurry and super P combination, which say you might apply where you bring cattle slurry to an outblock, but you're not getting the full rate on, so you're applying some super P, that was pretty much as available. These struvites were looking good. They got more into the plant. However, the ash and the dairy sludge didn't seem to be quite as readily available. But that wasn't the end of the story. We looked at the full first year of cuts. Here, the super P got up to 15% recovery, matched by the cattle slurry combination. The struvites again looked good. And if we go over to the dairy sludges, we see quite a contrast here. The aluminium precipitated activated dairy sludge, that was just as good as the super P for supplying phosphorus over the course of the first year, whereas the lime treated dairy sludge was not. And you might say, well, maybe that lime treated dairy sludge isn't as good. And it doesn't seem to be supplying the P as readily in the first year, but we're also interested in how can these supply P over time. So when we bring in the second year data, this is interesting because that lime treated dairy sludge has now supplied as much phosphorus to the plant as did that application of super P fertilizer. And here, the cattle slurry combination with super P is moving ahead of the super P only. And I suppose this just points to one of the benefits that's there of getting some cattle slurry out on ground that maybe is far away, maybe you're managing with just bagged fertilizer, getting some cattle slurry to it can improve the amount of P that you're getting into the plant. The dairy sludges had a difference. And we went on a third year. And again, here we see quite marked differences with the cattle slurry benefit really coming in there versus the super P. And these dairy sludges over a longer trajectory doing at least as well, if not better, than the super P. So I suppose the message from this trial is really that there are opportunities there with slurry and for these bio-based fertilizers as we go over time. Now, one of the other elements that we work on in Johnstone Castle and try to integrate into the work that we're doing is looking at the soil biological health. We looked at the earthworm biomass in a sister set of these plots, which were essentially demo plots where we integrated these fertilizers into a fertilizer program such that they were applied with every split, so not just once up front, which is the typical approach to look at the P recovery, but integrating them as a farmer would. And what we see here is that comparing to the mineral fertilizer NPKS only, so that's your bagged fertilizer, using cattle slurry as part of that fertilizer program increased the earthworm biomass number, so it was actually double. And these bio-based fertilizers also seem to be beneficial. So look, I suppose that's the tip there. Bring in cattle slurry or these bio-based fertilizers has potential to be beneficial compared to just using mineral fertilizer. So on the I suppose the point of slurry, we really have a chance to up our game with our slurry management. And driven, I suppose, by the savings that we can make by doing so. I think it was in 2018, based on looking at this nice survey work of Trish Berry from 2013, where she looked at a whole range of slurries, and she found that there was a massive variation in the NP and K content of slurries that are out there. And William Burchell has recently done an update to that work on Dairy Gold Teagasc Joint Program farms, and again seeing that massive variation. And William and I wrote an article in Today's Farm, the Teagasc Today's Farm magazine from January, and that work from William is reported in there. But really the main point is that, look, we take in fertilizer, bagged fertilizer. It has a nutrient label on it. I don't think we'd accept it without a nutrient label. Yet we have all this resource of slurry, and we only have, I suppose, a coarse estimation of what nutrients are in it. If you use the book values that are there, that's better than using no information. But if we want to up our game, testing the slurry and getting a nutrient value is a tip that can be that I think can help us to improve our game with slurry and realize some savings then on the fertilizer side as a result of that. And look, it is an extra thing to do, and it is an investment of maybe 60 to 90 euros. But look at it, with the current fertilizer prices, you wouldn't get a lot of fertilizer for 60 or 90 euros, as we know. Look, and I suppose there's those long-standing tips there also around soil testing, so you know where are the fields to target that slurry to. Often the silage ground has a big demand for K. You're pulling off a lot of K, and you can see here in those slurry samples, even whether you're at the low end or the high end or the average, it's potassium that is the nutrient that's in greatest abundance in slurry. So getting that back to the K demanding area is important. And look, I suppose with the low emission spreading, there's a chance to spread on grazing paddocks without contaminating grass, which is an opportunity. But just watch out for the K side of things and look at your soil test. If you've got soils that are grazing pastures that are high in K and you're adding a high K fertilizer, which is what slurry is, to it, you might run into issues with grass tetany or leave yourself short on K for your silage ground, which you then have to purchase as fertilizer. And as we've talked about already, there's that additional benefit of the P availability when you combine or use when you use the slurry to deliver P. Just to touch briefly on this picture that you see up here in the top right, again from work that William Burchell did at Johnstown Castle, William found that where you got the slurry rapidly into tanks, so it wasn't sitting around on collecting yards, that retained more of the nitrogen in the slurry. So there's more nitrogen there to start off with, and it's not, if you like, blowing away as it's sitting around on the concrete. So if you can get your tanks, if you can get slurry off collecting yards and into tanks, and that holds more of the nitrogen there in your slurry store. So look, getting the nutrient label will help us to meet the challenge of getting the correct nutrient rate on each field in each crop. And knowing that base amount of what you put out in slurry, so you need to know the rate that you're applying it at, and then that label will help you to get a better number on what you've applied, which, working with your advisor or your technical sales agronomist, you can fine-tune the NPK requirements for fertilizer. And really this year is a year for prescriptions for each field with the cost of fertilizer. And how well you do that is really going to define where you sit on that podium of performance, if you like, for production and also for cost savings. Look, it's been said many times at this point, but using the low emissions spreading technology, the nitrogen that you're going to save this year using those spreaders is more valuable than it ever was. If you took the example here, going from, and bearing in mind what I said about the variability, but these rough kind of average rules of thumb, if you move from summer using a splash plate to spring using a low emissions trail and shoe or dribble bar, you're going to save about 6 units. And to put it in money terms, for a 2,500 gallon tanker going to the field, that's about 20 euros extra just by making that change for every tanker. And so that adds up as you spread a tank. So the tip is use the low emission spreading because it retains that nitrogen. It's helping us on the emissions front, but it's also nitrogen that's retained to grow grass on your farm. And that gives an opportunity to adjust downwards the bagged nitrogen to account for that extra saved nitrogen. And you should do that. Now look at, I suppose, on the nitrogen theme, we've seen with the protected urea work that the form of nitrogen can impact the emissions while allowing us to sustain the same level of yield. But one question that has been coming up is, well, look, if I don't have nitrate there, will I have a yield penalty? So if I have more of an ammonium form, or urea, which is an ammonium forming fertilizer, protected urea is an ammonium forming fertilizer, would it have a yield penalty? So this is work that we just published in the last few months, where we looked at a grass sward that was fertilized with just a nitrate fertilizer, so only nitrate, all the nitrogen delivered as nitrate, versus only ammonium, all the nitrogen delivered as ammonium in the fertilizer. And there was no yield difference, no difference in nitrogen uptake, and no difference in nitrogen use efficiency between these two sources. We also measured emissions of nitrous oxide from both of these treatments. So they had the same level of production, but the nitrous oxide emission factor for the nitrate was almost 3 times higher than that of ammonium. So look, the form of nitrogen that we choose makes a difference. And this has implications for the compounds. Some compounds, the weighting is more towards ammonium than nitrate. And the Department of Agriculture have funded a new project that's going to look into that in more detail, which will be starting soon. I suppose that brings me on to protected urea. Many of you might be very familiar with it, and maybe some others not so much. So just very briefly, protected urea, it's standard urea that's protected from ammonia loss using something called a urease inhibitor. And that simply blocks the urease enzyme. It's not killing off the bacteria, for instance. It's just blocking the enzyme. It's fooling the enzyme into thinking it met urea, but it's actually met the inhibitor. And essentially, like slurry, ordinary urea loses ammonia, and that's loss of nitrogen that you paid for. And if you think about around about 40,000 tons of nutrient urea bought last year, that's losing, according to the EPA, around 15.5% on average. Now that varies depending on the weather conditions, but on average, that's the average value used. And using today's prices, that was about 11 million euros worth of nitrogen that blew away and also counted against us for emissions. The protected urea brings that loss down to around 3%, 3.3% roughly. So that differential there in ammonia that would have otherwise blown away but was saved and instead put, gives an opportunity to cut the protected urea rate by about 12% versus standard urea, while delivering to the plant about the same amount of effective nitrogen. So while protected urea might look a little bit more expensive per ton, granted all fertilizer is very expensive at the moment, with the potential to cut the rate, it's actually better value than standard urea. So think about protected urea like low emission spreading for urea. It's very effective, but you don't need that equipment. You just, I suppose, you pay the premium for it and you put it in your spreader and away you go. Now, I suppose that saving around ammonia in the shorter term trials that we've done in Cutting in Johnstown Castle and at other sites, and Brian McCarthy and Anya Murray have done some nice work in grazing, showing that all the fertilizers stacked up in terms of yield. But the question, I suppose, keeps coming up, what about, if we're saving this nitrogen from ammonia loss, why are we not seeing it in yield? And back a number of years ago, I set up this long-term experiment in Johnstown Castle where we repeatedly applied the same fertilizers to the same plots over time. So here's a 7-year data set where we compare urea, CAN, and protected urea. So everything is expressed relative to urea, this 100% line here. And if we bring in the CAN performance over those 7 years here, we see that in 5 out of 7 years, CAN is above the urea line in terms of its relative yield, or yield relative to ordinary urea. So bringing in the protected urea, we see that in 6 out of 7 years, it's above that urea line. And it's 2018 that we see them, let's say, fall below the level of standard urea. But I wouldn't read too much into that, in the sense that in 2018, it was water that was the limiter here. None of these plots were limited for nitrogen. They all had enough nitrogen. Simply water was the limitation. So how much extra did they grow? Well, the fertilizer didn't grow all of this yield, as it doesn't on your farms also. The background grew a portion of the nitrogen. So it's really this difference here that the fertilizer actually grew. So if we look at that, that additional yield over this long-term experiment with repeated application and exclude that drought year, can give us an additional 9% over urea, and protected urea an extra 13% over standard urea. So look, at what we're seeing is that protected urea, it does stack up for the farmer in terms of yield, certainly in cost, which I'll have a slide on a little bit later, and it gives us that emission reduction that can go straight into the inventory. Now, one of the many questions that has come up around protected urea is, would there be a soil health effect of using protected urea? And look, unfortunately, we have these long-term plots, and our soil microbiologist, Fiona Brennan, along with her colleague Aoife Duff, have actually taken soil from these long-term plots and looked at the soil microbial community in a very extensive way, but essentially no effect of the urease inhibitor on the microbial community composition or diversity is what they found. And there's a paper currently in review on that will be published here in due course. I suppose another tip that we have from some work that my PhD student Claire Aspel has published in the last month or so. This is looking at sulfur and its potential benefit in swards. So in this experimental setup, you can see plus sulfur and without sulfur, and visually you can see a difference there. This was an experiment conducted in a soil that was quite responsive to, very responsive to sulfur. It was a light textured sandy loam soil that was free draining. And some tips from that paper that's been recently published. Claire saw up to 2.9 tons of additional dry matter with the use of sulfur on this particular free draining sandy loam soil. Now, it's important to say that not all soils will respond to this level, and that brings me back to the first slide that I showed you. Your knowledge of your own farm really trumps this type of information. This is giving you a guide, but you can really fine tune it by that knowledge you have of your own farm. But that was the magnitude of benefit that she was seeing. Importantly, with this challenge also, not only in atmospheric emissions, but in losses to water and water quality, Claire saw that inclusion of sulfur reduced nitrate leaching by 46%, and importantly kept the nitrate leaching levels coming out of this soil below that drinking water standard, whereas where sulfur wasn't included, there was levels of up to 40 milligrams per kilogram coming out. So this is a potential solution and can help with water quality in areas that are struggling with water quality issues. You might be thinking, look, I'm applying slurry, that's covering me off for sulfur, I don't have to worry too much about it. Slurry is not a great source of sulfur. Quite a bit of the sulfur that's in the manure has volatilized off during the storage, and in addition, the sulfur that's there remaining, Claire found only about 9% of it was available. So just bear this in mind when you're thinking about sulfur applications and getting in a few rounds during the season, or making sure that it's adequately taken care of for your silage ground.
We have 2 minutes, Patrick.
Okay, so we're coming towards the end anyway. So look, hopefully you're hanging in there with me anyway. Claire has some work coming down that'll be coming on stream hopefully before too long, where she looked at response to sulfur across a range of soils. So a different sandy loam soil here giving 3 tons extra. So these lighter textured soils can be quite responsive to sulfur. So that if this is you and you have these type of soils, make sure you're taking care of sulfur and you're getting several rounds of sulfur into your fertilizer program for your grazing, and definitely for your silage. Other soils giving less of a response, and we have seen also soils that don't give any response. So you're going to be somewhere in that level. So think about what can you do on your own farm, particularly in this high price year. Is it worth your while to get a sulfur fertilizer and spread a stripe of it down the middle of a paddock? You know, maybe spread out nitrogen and skip something in the middle, and have a sulfur fertilizer there in the yard next, put it into the spreader and spread a stripe of that down through the paddock, and it's there in the spreader for the next go round. And you can have a look on your farm and see what kind of benefit you're getting from it. Doing that in the April-May time is a particularly good time to see that benefit if it's there. So in terms of which products should you use, on the protected urea side? Look, I know there's an issue there around supply and getting your hands on it. That's kind of an ongoing issue, but there are 20 products available from 6 fertilizer companies. Pre-ordering it may help. And I'm going to show you a little example now, which will highlight why it might be worth your while going to a bit of extra trouble to try and source it. You know, I recognize that for many of you, you're wondering if you can even get fertilizer, and that's an issue. That's an issue too. But let's just have a little look at the cost savings by fertilizer nitrogen choice. So if we take these example prices, now maybe you can buy these cheaper or dearer, but regardless, you should be able to plug your values into this calculation and make that calculation. So let's say with CAN at 700 a ton, protected urea at 970 and urea at 920. How much nitrogen are you actually getting in that ton of fertilizer? So at 46%, so just add a 0 onto these percentages and you have the kilograms of N in a ton. So for CAN, you're down at 270, and with the ureas, you're up at 460. And if you divide this value into the price, you'll have a cost per kilogram N, and you can compare them on the same basis. And you can see there, even though protected urea sounds expensive, and you know, you do hear people saying that it's not being stocked because it's too expensive. It's actually cheaper than CAN by almost 50 cents, which it would be an enormous amount in other years. And if you consider the potential for rate saving, it's actually better value than standard urea. And I'm supposed to look at this in another way. For that 460 kilograms of N that you can get in a ton of a urea product, how much would you have to pay for that if you were to purchase that same amount of nitrogen using CAN, which would be in a different tonnage amount, but the same amount of nitrogen? You'd be heading for 1,200 euros a ton. And if you scale that up to, let's say, 100 kilograms per hectare of straight nitrogen that could be inserted in a 40 hectare farm, that's almost a 2,000 euro difference or saving potentially there that could be made by using protected urea versus CAN product, even though the CAN appears cheaper per ton. And look, of course, all this will depend on what fertilizer prices do and how they change. That's why it's important to be able to do this calculation up here yourself and assess what's the best value. So look, thanks for your attention and bearing with me. If there's any questions, I'd be happy to do my best to address them.
Thanks, Patrick. You've really shown the deep knowledge that's there in Johnstown Castle with the whole soil and nutrient interaction there. And I just wanted to bring people's attention. Maybe Patrick, if you could just stop sharing your screen for a moment there, and I just want to share and give you a little break as well to share some of the details of the soil nutrient and fertilizer fact sheets that are available. And this is probably a good first step for people to go and look for advice around soil and soil fertility and best practice around fertilizer use, and to look at all of the different aspects of fertilizer planning. Highly recommend this section on the Teagasc website. And you can also look at the Teagasc YouTube channel. There's lots of information there about reseeding, and there was a number of webinars done in it last year that really gave good advice to people. And of course, good advice as well as to talk to your Teagasc advisor to see, you know, to get that advice. And I know Teagasc is planning a number of events throughout the year to do demonstrations on clover and clover management, because there is a management piece there that I think people need to be aware of before embarking on clover. So Patrick, a lot of questions, huge interest in this topic, obviously, because of fertilizer prices are putting a lot of focus on people's minds and how to actually address the issue. But just a couple of questions there I had there. You mentioned about testing your slurry. What's how does one go about doing that, and where can I go to get my slurry tested?
Yeah, that's a good question. So the practicalities of doing it. Look, the laboratories in the country, and most of them are doing slurry testing. So I suppose that's a matter of contacting your local lab, or the lab that you'd often use. So I suppose I don't want to start naming off labs, but there's a range of them around Ireland that do soil testing and that also do slurry testing. So if you can get your soils tested, you can also get your slurry tested. I suppose for taking a slurry sample, your health and safety is the very first thing that you need to be conscious of. You don't want to be taking any risks with slurry, but ideally you want to you do want an agitated sample that's been well mixed up, and the lab will advise you on what quantity that they need. It may be a litre, maybe less, maybe a little bit more that they require to get that analysis done. I suppose, thinking about it in practical terms, if you're agitating a tank and going off and spreading your silage ground, there's a potential there. You have an agitated tank, you've drawn the slurry up into the tanker. Maybe you have a gate valve on the tanker that you can safely access and take a sample from. Once it's gotten into the tank a little bit, you're keeping a good calibration on what rate of slurry you're applying. So you have that information. Did you apply 2,000 gallons, 3,000 gallons? Where are you at on that? You send off your sample and you get the information back, and then you've got your rate of slurry that you applied. You've got a label for your slurry that you can sit down with your advisor, and you know what's gone on, and you can then match up the mineral fertilizer requirement, and trying to be closer to what it needs to be. And I think that's particularly worthwhile given the high fertilizer prices. And it's an opportunity that's there, I think, that's ripe for the picking. And I know it's a bit of extra work. It is a bit of extra work, but I suppose if we want to get these gains, there's usually a bit of extra management there to be done. But I suppose if you don't feel that you can do that, going to the book values that are there and looking at those resources that are there on the Teagasc website, and indeed in that article that I mentioned in today's farm, drawing on that information that William Burchell did as part of that survey of the joint program farms, looking at the concentration of nutrients in different slurry stores, will help to get you closer than you might if you're using no information.
So you can access a copy of an online version of today's farm on the Teagasc website as well. And just finally, from my own perspective, you mentioned lime quite a bit. I know from my days working and as an advisor in Galway that the interaction with peat soils can give you mixed results. What's your advice around that, or just a bit of care needed, really, I imagine, when using lime in peat type soils?
Yeah, there is care there needed, and I mentioned mineral soils quite a bit for those values in the pH 6 range. But for the mineral soils, there's a lower optimal target, so you do need to be careful. And that's where going to your soil test, and your soil test being informed that it's a peat soil, will give you the guidance that you need in terms of rates that'll be appropriate for those peat soils with lime. And I suppose just on the lime point, I suppose you might be thinking, God, if I apply lime now, it's not going to give me that increase in pH. It's going to take some time for that to happen. Like all lime that's sold in Ireland has to meet at least a third of it being at a very fine level, which will be immediately available and reactive. So if you purchase lime, a ton of lime, at least 333 kilograms of that will be readily activated into the soil for increasing the pH. Often it's more, but in any case, it'll feed out over a number of years as well. So lime is giving you that quick rise, but it's also giving you a longevity to it at a very good value, the ground limestone. Yeah.
Right. Thanks, Patrick. Pat, a lot of questions coming in, particularly around that interaction between slurry and lime as well.
Yep, and a couple of our more scientific people are asking questions about I suppose the science behind correcting pH and the reduction of nitrous oxide. What's the impact? How does that happen?
Yeah, no, it's a good question. So in this particular study, having a higher level of pH was bringing higher nitrogen use efficiency or recovery of the fertilizer nitrogen by the plant. And I think this is, at least in part, the mechanism for reduced nitrous oxide emissions, just because the plant is taking up that nitrogen more efficiently. But there is ongoing scientific work there that's looking at, and some of it showing, that higher pHs can be associated with lower emissions of nitrous oxide emissions. So there may be also a pH effect on just how the bacteria that are driving that denitrification process that's producing nitrous oxide, or indeed the nitrous oxide that's generated through nitrification of ammonia, may be influenced by the pH. But look at it, it's an ongoing area of research.
Okay, quick question. CAN versus urea, is there any difference in production response for each product at different pH levels?
I think you broke up a bit there, Pat, but the question, I think, was, is there a difference in response for let's say that CAN versus urea or protected urea comparison at different pH levels? And look at, I suppose, over the last number of years, over the last, I don't know, I'm starting to lose track now, 8 or 9 years at this stage, probably, we've done many experiments across many different soils and many different pH levels. I would say generally in the acidic range, so less than pH 7, and we see similar performance between the fertilizers across a range of those soil pHs. And I'd say, like in the long-term trial as well, the pH of that trial has been falling over time, and I'm deliberately letting it fall because I want to see if there's any divergence in pH between the nutrient sources. But we see that same sort of trend of a benefit, a yield increase or a benefit for CAN versus protected urea across a gradient of pH.
There's a couple of questions have come in relation to the potential use of liquid fertilizers and where it fits in terms of efficacy and losses. Yeah, no,
it's a good question. So while I work a lot with granular fertilizers now, because I guess in Ireland that's the main portion of the market currently, at least. Before I came home, I worked for 5 or 6 years in North America, and where I was, it was all liquid nitrogen. So I've worked quite a lot with it. I suppose what I will say is, if you're set up for liquid, and you do have to be set up for it, obviously, like you have to be set up for anything really, it can be a good option, and it does bring certain flexibilities. I suppose there's a few things to be aware of when you're looking at liquid products. They may not all be the same. Let's say if you've got UAN, what are you dealing with now? So you're dealing with a product that's half of it is like CAN, if you like, it's ammonium nitrate, and half of it is urea. And that urea portion of it can be susceptible to ammonia volatilization loss, and how you apply that product is going to have an implication in terms of its potential for losing some of that urea nitrogen as ammonia. So for instance, if you spray it onto the leaf versus if you apply it with a streamer nozzle where it falls to the ground and has soil contact and is more, let's say, in a concentrated band that engages and goes into the soil. Also, there's opportunity there for using a urease inhibitor with it. And when I was in North America, that was pretty standard for farmers to add the urease inhibitor themselves to the UAN fertilizer. You know, that may not be the way that we want to do it here in Ireland, but that did happen there. If you've got a urea only product, which is dissolved urea, and then you've got all urea, so you need to be conscious of that potential for ammonia loss. There's also products that have acidified, that the urea is dissolved, but it's acidified, and that has potential to mitigate loss of ammonia from those products. So the liquids, they're not all the same, they're not applied in the same way. So you kind of need to hone in on which one are you talking about and how are you doing it. So there's potential to do it very well, I would say, and also potential to maybe be having some levels.
We're getting tight on time, but there is an important question there around protected urea. Is there any need for protected urea in February or March in wet or damp conditions? Is there a benefit in using it?
Yeah. Okay. So the question's around loss for protected urea. So if the conditions are wet and damp and dull, you'll typically have lower levels of ammonia loss from a urea fertilizer. And if those are the conditions that you're applying in, let's say the benefit of that insurance of the protection is going to be less because the urea has less loss. But if you remember at the beginning of February, we had lovely bright days, and as I drove around Cork actually in February, everywhere you went, you could smell the slurry. And when you can get that smell of the slurry, you also have conditions that are favorable to ammonia loss. So that was in February. You have, even though it's cooler, you have conditions that are, windy and bright, and they favor loss. And if that ends up being the February day that you apply in, protected urea is going to give you more benefit. From the inventory perspective, every ton of urea that we use or spread counts against us on the ammonia emissions front, and we were exceeding our target here, and we need to get under it. So the protected urea is bringing a benefit there as well, and there's a potential to cut its rate by about 12% versus the standard urea. And obviously that's going to change based on the weather conditions, exactly what will happen in a given field, but on a broader average. And I suppose this is where your management comes in as an important factor in saving money this year and every year.
Okay, we are up to 10:30, and I know there are other questions we didn't get to today, but maybe we'll just think about how we will address those. But a huge amount of interest in today's topic. So, Patrick, thank you so much for your time and the really excellent presentation. I really like the tips, that in each slide, it's very practical advice. And of course, people can look back on the presentation. I know there were some few technical aspects presented there. You can look back at that. We'll have that up on the Teagasc YouTube channel over the next few days. Just to let you know, next week we'll be speaking to Carol Quiche from the Mulcair project on-farm actions to improve water quality on the Mulcair catchment, which is down in County Limerick. So do join us for that next Friday. But also I want to draw your attention to an event, or series of events that are happening next week as part of the Agricultural Catchments Programme, and they're showcasing measures to improve Ireland's water quality. And the week will include a broad range of topics, including work being done by the Catchments Programme for the last number of years, and some of the organisations it has worked with since 2008. And it will also feature research advisory and technical work that the programme continues to deliver in partnership with catchment farmers. So do look on the Teagasc website. There's lots of different activities happening there around that really important project that's supporting Ireland's nitrates regulations. So a lot of information gathered by the project there over the last number of years. So we're going to play you out with a short video clip that promotes this week. And again, my thanks to Patrick and Pat for helping with questions. And I want to thank our backroom team, Yvonne Maher, for helping out with the technical side today, and our series producer, Andy Boland, and to all our partners. So we will see you next week.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review,
and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.